Top 30 Solutions Architect Interview Questions and Answers. A solutions architect plays a critical role in designing, implementing, and managing complex IT solutions that align with business goals. Interviewers seek candidates with strong technical expertise, problem-solving skills, and the ability to communicate solutions clearly to stakeholders. Preparing for the interview helps showcase your experience in architecture design, cloud platforms, scalability, and security. Below are the top 30 Solutions Architect Interview Questions and Answers to help you demonstrate competence and confidence. 1. What is the role of a solutions architect? A solutions architect designs and oversees the implementation of IT solutions to meet business requirements. They bridge the gap between business needs and technical execution by evaluating requirements, creating architecture diagrams, selecting technology stacks, and ensuring solutions are scalable, secure, and maintainable. They collaborate with stakeholders, developers, and operations teams to ensure successful deployment. Their role involves aligning technology with business strategy, mitigating risks, and providing long-term technical guidance across projects. 2. How do you approach designing a scalable solution? I start by analyzing current and anticipated workloads, identifying bottlenecks, and defining performance requirements. I choose scalable technologies, such as cloud platforms with auto-scaling capabilities. I use microservices or modular architecture to ensure components can scale independently. I also consider database optimization, caching, and load balancing. Continuous monitoring and testing are implemented to detect scaling issues early. Finally, I document the architecture and communicate with the team to ensure proper deployment and maintenance. 3. What is cloud architecture and why is it important? Cloud architecture refers to the design of applications and infrastructure hosted on cloud platforms. It includes components like compute, storage, networking, security, and services that work together efficiently. Cloud architecture is important because it enables scalability, flexibility, cost efficiency, and high availability. Proper design ensures applications can handle variable workloads, recover from failures, and integrate seamlessly with other services. It also allows organizations to leverage cloud-native services for faster innovation and reduced operational overhead. 4. How do you choose between on-premises and cloud solutions? I evaluate business requirements, cost, security, compliance, and scalability needs. On-premises solutions may be preferred for sensitive data or regulatory constraints, whereas cloud solutions provide flexibility and scalability. I consider long-term operational costs, available expertise, and integration with existing systems. Performance, downtime tolerance, and disaster recovery capabilities are also assessed. A hybrid approach may sometimes be ideal. The decision is based on balancing technical feasibility, business value, and operational efficiency. 5. Explain microservices architecture and its benefits. Microservices architecture structures an application as a set of independent, loosely coupled services, each responsible for a specific functionality. Benefits include scalability, faster development cycles, easier deployment, and improved fault isolation. Teams can develop, test, and deploy individual services independently, reducing the risk of downtime. Microservices also allow technology heterogeneity, meaning each service can use the most suitable tech stack. This architecture improves maintainability, resilience, and flexibility compared to monolithic applications, especially for complex, large-scale systems. 6. How do you ensure the security of solution? I perform threat modeling, implement authentication and authorization controls, and ensure data encryption at rest and in transit. I follow security best practices such as least privilege, secure coding, and regular patching. Compliance requirements, network segmentation, and monitoring for suspicious activity are also critical. I conduct security reviews and audits throughout the development lifecycle. Security is integrated into every stage, from design and implementation to deployment and monitoring, to mitigate risks and protect sensitive data. 7. What is the difference between SWA and microservices? SWA, service-oriented architecture, organizes applications into services that communicate over a network, typically with an enterprise service bus ESB. Microservices are smaller, independent services with decentralized communication, usually via lightweight protocols like REST. SLA often involves tighter coupling, centralized governance, and shared databases, while microservices prioritize autonomy, independent deployment, and scalability. Microservices are more flexible for cloud-native applications, whereas SLA suits enterprise systems needing standardization and integration with legacy applications. 8. How do you handle legacy systems when designing new solutions? I analyze existing systems for dependencies, limitations, and integration points. I determine whether to refactor, replace, or wrap them with APIs for compatibility. I consider phase migration, minimizing downtime and risk. Documentation, testing, and stakeholder communication are critical. I also evaluate performance, security, and compliance to ensure the new solution aligns with business goals. Balancing innovation with operational continuity ensures smooth integration and maintains service levels during transition. 9. What is the importance of data modeling and architecture? Data modeling ensures data is structured logically, supporting application functionality, performance, and scalability. It defines relationships, constraints, and storage requirements. Proper data modeling improves query efficiency, reduces redundancy, and maintains data integrity. It facilitates integration with other systems and supports reporting and analytics. Data models serve as a blueprint for database design and provide clarity for developers, enabling consistent and maintainable implementations aligned with business requirements. 10. How do you select a technology stack for a project? I assess project requirements, scalability, performance, and team expertise. I consider long-term maintainability, community support, licensing costs, and integration with existing systems. Security, cloud compatibility, and deployment complexity also influence selection. I evaluate trade-offs between technologies and prioritize those that meet business needs effectively while enabling agility. Documentation and alignment with enterprise standards ensure the stack is sustainable and well-supported throughout the solution lifecycle. 11. Explain the concept of high availability. High availability ensures a system remains operational with minimal downtime, even during failures. It involves redundancy, failover mechanisms, load balancing, and monitoring. High availability reduces the impact of hardware or software failures, network interruptions, or maintenance events. By designing fault-tolerant architecture and distributing workloads across multiple nodes or regions, systems can continue to serve users reliably. High availability is critical for business continuity, customer trust, and service-level agreements (SLAs). 12. How do you approach cost optimization in cloud solutions? I analyze resource utilization, identify underused services, and implement auto-scaling to reduce unnecessary costs. Choosing cost-effective storage, compute, and networking options is essential. I leverage reserved instances or savings plans for predictable workloads. Monitoring, tagging, and reporting allow detailed tracking and accountability. Continuous assessment ensures cost-effectiveness without compromising performance or security. Optimization involves both architecture design and operational discipline to maximize ROI in cloud deployments. 13. How do you ensure performance and reliability in your solutions? I define performance requirements and conduct capacity planning. I implement caching, load balancing, and asynchronous processing to reduce bottlenecks. I perform stress and load testing to validate architecture. Monitoring tools track metrics in real time, allowing proactive issue resolution. Redundancy, failover mechanisms, and disaster recovery strategies ensure reliability. Regular reviews, testing, and optimization maintain consistent performance under variable workloads, aligning the solution with business expectations. 14. Explain the CAP theorem in distributed systems. The CAP theorem states that a distributed system can guarantee only 2 of 3 properties simultaneously: consistency, availability, and partition tolerance. Consistency ensures all nodes have the same data. Availability guarantees that every request receives a response. Partition tolerance allows the system to function despite network failures. Architects must prioritize which 2 properties are most critical for the application, depending on use cases and business requirements, as no system can fully achieve all 3 at once. 15. How do you handle system integration challenges? I analyze APIs, data formats, protocols, and dependencies before integration. I implement middleware or adapters when needed and design robust data mappings. Testing is critical to ensure accurate data flow and error handling. I collaborate with multiple teams to ensure proper alignment. Monitoring and logging help detect integration issues. Clear documentation and standardized approaches reduce complexity. A structured, proactive approach ensures systems work cohesively while maintaining reliability and security. 16. How do you design a solution for fault tolerance? I implement redundancy across components, including servers, databases, and networks. I design failover mechanisms and load balancing to distribute workloads. I use replication, backups, and monitoring to detect failures quickly. Testing recovery scenarios ensure systems continue operating despite faults. Documentation and procedures for recovery are critical. Fault-tolerant design reduces downtime, mitigates risks, and ensures critical services remain available under adverse conditions. 17. What are the key considerations for migrating to cloud? I consider security, compliance, cost, downtime, and data integrity. Assessing existing workloads, dependencies, and performance requirements helps choose appropriate cloud models. I plan phased migration, testing systems at each stage. Backup and rollback strategies mitigate risk. Ensuring staff are trained on cloud operations and monitoring tools is essential. The goal is a smooth transition that maintains business continuity and maximizes cloud benefits like scalability and flexibility. 18. How do you design for disaster recovery? I implement geographically redundant systems, automated backups, and failover strategies. Recovery objectives, including RTO, recovery time objective, and RPO, recovery point objective, guide planning. I test disaster recovery plans regularly to ensure effectiveness. Monitoring and documentation are critical for preparedness. Clear communication with stakeholders ensures everyone knows roles during an incident. Disaster recovery design minimizes downtime, protects data integrity, and ensures continuity of critical business services. 19. Explain containerization and its benefits. Containerization packages applications and their dependencies into isolated units that run consistently across environments. Benefits include portability, scalability, efficient resource utilization, and faster deployment. Containers simplify testing, reduce conflict between environments, and allow microservices to be deployed independently. They integrate well with orchestration tools like Kubernetes, supporting automated scaling and self-healing. This approach enhances development efficiency, operational consistency, and overall system reliability. 20. How do you choose between relational and NoSQL databases? I evaluate the data model, consistency requirements, scalability, and access patterns. Relational databases are ideal for structured data, strong consistency, and complex queries. NoSQL databases suit unstructured or semi-structured data, flexible schemas, and high scalability needs. Performance, cost, and integration with existing systems also influence the choice. The decision aligns with business requirements and expected growth while ensuring maintainability and data integrity. 21. What is the role of APIs in architecture? APIs allow different systems to communicate, enabling integration, modularity, and extensibility. They define contracts for data exchange and functionality. APIs support microservices, third-party integrations, and automation. Well-designed APIs improve maintainability, security, and scalability by decoupling components. They also enable developers to build on existing services efficiently, supporting innovation and faster delivery while ensuring consistency and interoperability across the architecture. 22. How do you handle versioning in solutions? I implement version control for code, APIs, and infrastructure changes. For APIs, I follow semantic versioning to indicate backward compatibility. For software, I maintain branches for development, testing, and production. Documentation of changes ensures team alignment. Versioning enables rollback if issues occur and minimizes disruptions. It maintains stability, supports collaborative development, and ensures that clients and services interact with compatible system components. 23. What is the difference between monolithic and distributed architectures? Monolithic architecture is a single, unified application where all components are tightly coupled, making deployment and scaling challenging. Distributed architecture breaks applications into independent services, often running on multiple servers or cloud instances, improving scalability, fault tolerance, and maintainability. Distributed systems may involve microservices, event-driven design, or service-oriented patterns. Monolithic systems are easier to develop initially, but distributed architectures offer flexibility, reliability, and performance for large-scale applications. 24. How do you implement monitoring in solutions? I deploy monitoring tools to track application performance, availability, and resource usage. Alerts are configured for thresholds or anomalies. Logging captures errors, user activity, and system events. Metrics are visualized through dashboards for real-time insight. Monitoring helps detect issues early, optimize performance, and support proactive maintenance. Regular reviews of monitoring data ensure reliability, capacity planning, and continuous improvement of system operations. 25. How do you ensure compliance in IT architecture? I follow regulatory frameworks such as GDPR, HIPAA, or PCI-DSS depending on the industry. I implement data protection measures, audit trails, access controls, and encryption. Documentation ensures traceability of processes. I collaborate with compliance officers and conduct periodic reviews to ensure ongoing adherence. Integrating compliance into architecture design prevents violations and supports security, privacy, and legal accountability. 26. How do you handle multi-cloud architecture? I design solutions with abstraction layers to ensure portability between cloud providers. I consider networking, security, cost, and service compatibility. Load balancing, redundancy, and monitoring are critical. I select cloud-native tools that allow integration across providers. Multi-cloud strategies reduce vendor lock-in, improve resilience, and optimize costs. Careful planning ensures applications run consistently while leveraging strengths of multiple platforms. 27. How do you approach cost estimation for a solution? I analyze resource requirements, infrastructure, licensing, development effort, and operational costs. I consider scalability, high availability, and potential future growth. Risk factors and contingency planning are included. I collaborate with stakeholders to align the budget with business objectives. Accurate cost estimation ensures projects remain financially viable while meeting performance and reliability requirements. 28. Explain the importance of load balancing. Load balancing distributes traffic across multiple servers or instances to ensure availability, reliability, and optimal performance. It prevents any single server from becoming a bottleneck, reduces downtime, and improves scalability. Load balancers monitor health checks to reroute traffic when failures occur. By optimizing resource utilization and response times, load balancing enhances user experience and supports high-traffic applications. 29. How do you approach technical debt? I identify areas where shortcuts or outdated designs may create future maintenance challenges. I prioritize technical debt based on impact and risk. Refactoring, code reviews, and updating documentation reduce debt over time. Balancing delivery speed with long-term maintainability is crucial. Addressing technical debt ensures system reliability, performance, and scalability, while reducing the likelihood of costly issues in the future. 30. How do you communicate technical architecture to non-technical stakeholders? I use visual diagrams, analogies, and simplified explanations to convey complex concepts. I focus on business benefits, risks, and outcomes rather than technical jargon. I highlight how decisions impact cost, scalability, and reliability. Regular updates, presentations, and documentation ensure alignment. Clear communication ensures stakeholders understand the value and implications of architectural decisions and fosters trust and collaboration. Solutions architect interviews evaluate technical expertise, problem-solving, communication, and strategic thinking. Preparing thoughtful, experience-based answers helps demonstrate your ability to design secure, scalable, and maintainable solutions. By highlighting your knowledge of cloud platforms, architecture patterns, integration, and performance optimization, you convey competence and confidence. Careful preparation ensures you are ready to articulate your skills, approach, and value as a solutions architect, making a strong impression on interviewers.